entertainment, insights. Don't take life too seriously. Welcome to Brainski Unleashed. Welcome to the program today. I am thrilled to be joined by Scott Mappin with Strategy Milling. He shouldn't even need an introduction, to be honest with you, because the man is actually legendary. He's really a one of a kind. In the dental field, there's a lot of technology and a lot of creativity as far as how things are fabricated, but there is only one man that I know of who has literally gone to the lengths of taking solid gold, basically, and milling it out into teeth. And this is not something that anyone else would do. It generates a tremendous amount of waste. The man has been called crazy, I'm sure, many times by many other people, yet he does this in a way that is profitable and ingenious. From my dental lab experience, I could tell you his product is second to none. And so I'm thrilled to be able to have him on and go over some of what it took to make Scott Mappin the legendary visionary man that he is, and we'll hopefully gain some insight as to how a brain like that thinks. And I'm sure it's at least going to be an entertaining interview at that, because the man's also got a wildly excellent sense of humor. So welcome to the program, Scott.
Thank you, Tom. Wonderful introduction. Thanks. I'll send the check right away.
I appreciate that. Just make sure you spell Brainski properly. If you don't get the Y at the end, the bank tends to have an issue.
Got it. Yeah, we don't want any questions.
Absolutely. So, Scott, let's start with the fact that you are unique. There is no one else really that does it exactly like you. So, in the milling space, and I'll explain this to anyone who's listening who has no idea what we're actually talking about, there are options for teeth crowns, right? That are fabricated. People can do it a very old way. It's a very labor-intensive process. Design something in wax, handcraft it, then you invest it into a material, so you have this, a perfect matching cave, basically, and then you can, melt gold and it gets injected into that, and out of that comes the exact shape of that crown. And then it's got to be finished, and it's just a very big process. Other ways are laser melting. It's a different type of technology, but then you somehow, in a crazy way, decided you were going to literally make discs of gold and then take a milling machine and mill out these crowns out of discs of gold.
Right.
Wow. Nobody does anything like that I'm aware of. What made you decide to go that route? It's crazy.
Ignorance, part of it, to be honest.
I believe that.
Not knowing and trying to find a way and looking around at what was available. When you looked at all other mills and what they were milling, from PMMA to denture bases to zirconia, and we didn't want to go to a block method like lithium disilicate. It was always a disc.
But all of these methods that you're talking about are essentially, it's reductive manufacturing, meaning that you are generating waste as you reduce down to the final product.
Right.
You're wasting gold. I mean, the other ones, yeah, you could waste plastic. It's plastic.
Sure. So the conversation, what's the real genesis of Strategy Milling was a conversation I had with my brother, Don, who owns Atlantic Precious Metals. I left this area. I'm in Pittsburgh. I left this area. I grew up in New Kensington, about 20 miles outside of the city. I left in 1990 after a divorce, and just wanted to get the heck out of town, and ended up in Vermont. And I spent 22 years doing different things and moving around the country. And when I came back for a job at a well-known laboratory in Irwin, Pennsylvania, to be something like the assistant general manager and intraoral expert on their staff, and they were quite large. After 5 months, I resigned the position. It was uncomfortable we were family friends, the lab owners and my family. And it got to the point where I was sharing the office with the owner, and we were having a meeting one day, and I was uncomfortable. I wasn't happy. He was uncomfortable and unhappy. Excuse me. And I said, listen, it's not worth it for either one of us to do this if we're feeling this way. So I'm going to resign if you're okay with that. And within half an hour, I was out the door. We shook hands, gave each other a hug. I knew I would find something else to do. I wasn't worried about that. And I called my brother and he said, come on down to the refinery. We'll put you to work. And I jokingly say he did that so I wasn't sleeping in his basement. He's going to make sure I have a paycheck and I can have an apartment someplace, so I'm not bothering him. And that was September of that year, I think, of 2011. 2011. And by Christmas, I was trying to add value to his business by writing SOPs, learning how to operate different pieces of machinery, doing a website development stuff for them. And it wasn't really what I wanted to be doing, but he gave me a job. I'm gonna push. So it was like Christmas Eve or the day before Christmas Eve in his office. And he said, why isn't anybody milling gold? And he was out at that laboratory because they were a customer of his for scrap. And he had just seen their digital designing center and some of their zirconia milling. And so that was his, wow, now I understand what these guys are talking about a little bit. And so he asked, why doesn't anybody mill gold? And I said, that's the dumbest effing thing you've ever said. And
right.
Two brothers sitting in his office. What else do you think my response would be? And they said, yeah, I don't know about that. He goes, if milling has value related to consistency, efficiency, production, all these different things, then swapping out the medium means you're applying those same values to that medium. So I don't understand what you're talking about. And I said, well, when I worked at Issaquah Dental Lab, where they had multiple lava mills, we were taking material out of those mills with little shovels, to clean the mills out. It's a huge waste generator.
Massive.
And he just looked at me and he goes, I don't know if you realize that you're sitting inside a 15,000 square foot scrap refinery. I know what to do with waste. I don't know how to mill, and that's what you know how to do. And that was the moment that the light bulb went on. And I went, holy crap, you're the only one that this actually makes any sense for, because you have the systems and protocol in place to manage scrap. So
to take the waste and turn it into a reusable.
Right.
Yeah.
Right. So that was Christmas 2012. 2011. I went in 6 weeks, I had a business plan written. I went to the Chicago Midwinter meeting, and my job at that year was to look for every milling machine on the market and gather their information, which I did. Rotors of Germany happened to be there, which they are very rarely.
They're never there.
Yeah, it was.
So that was like perfectly timed.
Yeah, I think that was the last year they actually showed up. And when I got back, I made a spreadsheet of all that data. I got rid of everything that wouldn't cut metal, because you have to have a pretty strong spindle to cut metal well.
Yeah.
And then I was already working on the process at his refinery. We were going through, trying to answer the question, how do you make a disc of dental alloy? So we were invested pretty heavily with material and some equipment that we were trying out to try and come up with this process. It took the better part of 2012 to dial that in to even have something respectable.
Massive amounts of R&D that you're talking about, and you don't even have a single customer to support you yet.
No, this was all just, can we make this bird fly?
Wow.
And then in the meantime, we were in conversations we landed with Willemin Macadel, Rotors, and DMG as our milling platforms of choice. Here we are again on another path making discs. And we talked to Willemin Macadel, who has a very nice machine. I would put them right next to Rotors at the top of the list of
any day. High end quality.
Right. But at the time, they didn't have automation for discs. They had automation for bar stock. And their sale was, why don't you change that and make bar stock? I'm like, I just spent a lot of time trying to figure out how to make a disc. I'm not really interested in throwing that out the window. We have something here. Let's keep moving forward. And it wasn't like there wasn't another option. So DMG and Rotors, I interviewed them. DMG, for what it's worth, I'm not knocking them as a company, but I knew I was going to need a lot of technical support, because I really had never run mills that were this sophisticated. So, support was going to be one of those things that was key to our success. And when I started talking about that with DMG, they'd say, well, you'll call your rep. Okay, what if the rep doesn't have the answer? Well, then you'll call this person. And what if they don't have? And I just kept asking over and over again. And what if they don't have the answer? And I'm I'm seeing a multi-layered stack of people that I have to get through. That's time delays, that's inconsistent information, right? There's a lot of things that are going to happen if I have to reach through 6 or 7 people to get my answer.
I'm going to stop you there for a second, Scott, because you've identified something that to me, also being a lab owner, is so critical, and it's one of the biggest mistakes I think uh, a lot of dental labs make. I'm sure other businesses, in this respect, is support is such a critical component, and we all talk about it, but when you really get down to it, it can't just something it can't be something that people just talk about and agree on. It has to be something where, yes, the rubber meets the road. Support is
Right.
so incredibly
Right.
critical. You may get yourself a really great price on a machine, or you may deal with a company that's really flashy and does great marketing, but how screwed would you be when that machine is down?
Right. And look what we were about to do.
Oh,
Right. We're doing something nobody else does.
right.
So at the time, that was the position we were in. So it was a highly critical piece of our plan moving forward that we had support. When Mr. Pfister from Rotors showed up for the interview, I went through my same set of questions with him, and I said, if I need support, who do I reach out to? And he said, our support staff, our service center in New York will handle your call. And what if you don't have the answer? And he just looked at me dead in the eye, took about 5 seconds. This is a brilliant sales pitch, if nothing less, and said, if you would like Mr. Rotor's phone number and your cell phone, I will give it to you.
Wow.
And
Now
so,
that's another point right there, because again, this is where labs make whopping mistakes. Technically, New York is local support.
right,
You don't want to buy a piece of equipment, even though you might get a spectacular deal on a piece of equipment. If your dealer, if you're dealing direct with the manufacturer, whatever it is, if they are from Europe or Asia, which you have a lot of options in these two areas, most of the mills that are made come from these two regions, mostly. If you're getting a sweetheart deal, but you don't have support, you basically have nothing.
cat in
You
a bag.
got a brick.
Yeah, it doesn't do it. It just got a big paperweight in your office. So
Completely. Yeah.
yeah, so that sold us. And then we said, well, that's great. We have a puck, but I'm not buying a mill until you show me that you can cut my crown at this speed within this many minutes and at this quality level.
Now, when you
So
said, I'm going to dive a little
yeah,
bit into the weeds here. Now, you mentioned speed. Did you have a speed? How did you have a speed in mind? When we talk about milling, we think in terms of speeds and feeds.
right,
How much the burr is going to eat and how fast the spindle has to spin while it's eating the material.
right,
Did you have a speed and feed in mind, or when you say speed, you were like, I just know that I want to cut this thing in 10 minutes?
right. It was
Wow.
that we're talking about, because the business plan was based on a hypothetical set of what's our production going to yield. So if we're going to do this, how many crowns a day, how many crowns per machine, how many crowns a month, like how many do you want to make? What's out there? What's the volume of crown? How many crowns are still being made in the United States? We did a nationwide market research with the largest dental focused marketing firm in the United States. And we searched, we sent questionnaires out. They sent the questionnaire out to the survey out to a couple 100,000
I think I
doctors.
know who they are, but that's okay.
Yeah.
Yeah.
And then we also looked at, we have something very unique in this country that I think a lot of people don't pay much attention to, other than how it affects their day to day. And that's the Identity Council. And if you're an NADL member, I believe that's what it takes, and we are, of course, you can reach out to Mr. Bennett and get a report on last year's Identity sticker sales.
Mhm.
So you can find out how many, if you have a laboratory, or you
So
provide.
just explain for the audience what is very quickly, what are you talking about when you say Identiloid?
Right. So it's a voluntary program where you tell the Identity Council, I'm going to produce a product and it's going to be made from this material. And here are the specs on that material. In our case, it's elemental content of an alloy. And it has those things listed, and it talks about whether it's a noble or a high noble or a non-noble type of material, which are all industry terms. Basically, precious, non-precious, semi-precious, those types of things would equate. And so then you buy stickers that show who you are as the manufacturer and that you're providing this product. And so every day, as most labs in the United States do, when products go out the door, there's an Idenalloy sticker that's a two-part sticker, goes with every case. Now, if you send a single unit, you send a single sticker. If you send an 8-unit bridge, you send a single sticker.
Right.
So there is a variable in the number you're going to see from the Idenalloy Council report, but it's a soft number in your favor, right? If you're trying to do what we were trying to do, which is figure out how many gold crowns are actually being made in the United States, so we know what our market is, that's a great way to figure that out. And they don't have that, I don't believe, in Canada or in Europe as a standard process. So it leaves, it's a big hole, if you ask me, for new development of dental businesses across. I don't know if they have something else that they can lean on, but for us, it was the Idenalloy sticker. So we saw the volume of crowns that are available.
So that, by the way, is that is a brilliant move as far as marketing research goes, because yeah, you're right. You can't tell the specific number of crowns that were made based on whether it's a precious metal, whatever it is, but you can at least see how many cases were produced. So now you have a really good, a good read on the market. So good for you for doing that.
Thank you. Yeah, I mean, so to see that there might, I mean, even today, you might, I don't know what the number is. I haven't looked. But if you saw that there were 1 million stickers sold between the two categories, a high noble and a noble gold crown, that's a soft number. There's more than 2 million that have been done, because we do 300 bridges almost every day here, or bigger. And so what if I have, pardon me, if I have 3 mills, which was what our intention was to purchase right out of the gate, how many, what am I chasing? Am I chasing 3/4 of the available market, or am I chasing 2% of the available market? What's the math tell me is available? And so now you can start to see, and I again, I haven't looked at the Idenalloy numbers in a few years, but if you consider all metal substructures and full contour restorations, and you took all the companies in the United States in dental that have the ability to mill metal, because that's a specific group of type of mills, there would be no way. The capacity is far beat by what's actually happening in the market.
There's no capacity compared to the volume.
Correct. Yeah. So the problem for us, so we solve that problem looking at that data and go, okay, we can throw that. We don't have to pay attention really to that much anymore, because there's enough work out there. If we just, now what? So how do we want our business to present to the industry? Because it's not like we have to chase down 75% of the crowns in the United States to be successful. It's more like 1 or 2%, and you have a successful business. So the scale of the industry comes into focus. You realize your place in it and how small it really is. And that piece isn't something that I really need to spend a whole lot of time focusing on. I can spend my focus being on, what do I really want Strategy Milling to provide to the industry?
But okay, I'm going to stop you there, because again, there's a lesson to be learned here. Essentially, Scott, you're teaching the way to do it right. I think a lot of people who may work at a lab and they want to start their own lab, they go in with the passion of the work, right? They want to start their own lab. Maybe they got burned by a lab that they were working for, and I'm going to compete. I'm going to steal their clients. I'm going to do this. And they go into it without any thought. They just dive right in. I'm guilty of it. They dive right, make a lot of mistakes. They dive right in, and they don't know the market at all. And typically they get burned, and then they get pigeonholed, and then they can't grow beyond whatever they were able to sell, because they don't have any understanding of the market. So again, good for you for doing the forethought. I mean, you're doing all of this before you even signed a contract on a mill.
Yeah.
That's brilliant. Most businesses, at least in this sector, in the dental lab sector, they would buy the business, start the business, run the business, operate, do whatever before they ever do any homework first. You went the other way. Again, that's one of the reasons why I believe that you're as successful as you are. So continue.
Yeah. So, and again, thank you. So I had a lab in Vermont. I have had two labs in my career. I'm 59, and this is my 44th year of being in dental. Although the last 10 or 11 or 12 years, since Christmas of 2011, I basically did a career shift. I'm now the operator of a foundry and a machine shop. The widget is still dental, but the amount of dental knowledge that I use day to day that I had used in my previous jobs at the bench or trainer or working for 3M, I don't use any of that anymore.
You went outside the box.
I understand where we're trying to go for the industry, but so as a lab owner in Vermont, one of my customers called one day, and my office manager answered the phone, and she came into the lab and she said, Dr. Steve wants to know if you do zirconia crowns, lava crowns specifically. Do you do lava crowns? And that was back when lava coping, right?
That's when it was all
lava coping.
Yeah.
And I said, tell him yes. And she went back in and said, yeah, he does them. And Steve said, I got some cases for you. Great. So then she came back in and she goes, what's a lava crown? I said, I don't know. Get online and try and figure it out, because I'm not going to turn down that business. And I don't know what this is, but we're going to see what it is. And then I outsourced to Issaquah Dental Lab, who as so many labs did. They were kind of the go-to milling center in the beginning of 3M's lava product.
Oh, I'm pretty sure David Lesh with Dale Dental argued that point.
Okay, well, perhaps. No, that's Dave. I wasn't even aware of David when I started doing that, right? Living in Vermont in a bubble up there.
Clearly, he wasn't marketing well enough, and I'd be happy to rub that in. I know David very well, so I'm going to have to rub that in.
Right. So I started outsourcing our lava copings to Issaquah, and that's back when you had to pour up your models and articulate everything in trim dies and send it all out in the post office in a box, not emails and scans, and get things back. But by the time things came back, Dr. Steve's a great customer of mine. He appreciated all the time and effort that I put into the case manufacturing, and I'm receiving copings from Issaquah with chip margins on that coping. Now I have about a day and a half left in my timeline to get that product to my doctor. If I disappoint Dr. Steve and lose him as an account, Issaquah loses my business. That's a bad thing then, as an outsource vendor, to be providing products that are inferior. That's how I saw it from my seat.
Absolutely.
So I'm taking lava copings and trying to put porcelain butt margins on them to fix them before I can put my porcelain on. So I'm adding steps, I'm adding time, I'm adding labor, I'm adding, all the while trying not to lose my account. So I was pretty observant of that whole experience. And when we started to plan out billing strategy milling, what do I want the customers of strategy milling to say about strategy milling as they receive our product? And there's an old American philosopher who he went to study philosophy in Asia and then came back and translated it into English so that we could read it. And one of his comments that's always stuck with me was, live your life in a way that even if someone lies about you, they can't say anything bad. And so I feel like that's what we've tried to do. And look, strategy milling is not perfect. We have sent out products that have gotten past our QC. I think you've even received one or two of them over time that aren't right. And that's just part of any manufacturing process. So I'm not here saying strategy milling is perfect by any stretch. But if you shoot for perfection, you can land at excellence. And I feel like we've done that.
Yes. Scott, I'm not about to trash your product because I love your product. It's you do follow your own philosophy. I'll back you up. I will attest that you do follow that. Yes. I think out of the hundreds of units that we've done, if not thousands of units that we've done at this point with you guys, what have we had, like 3 that weren't right? And every single time you have resolved it and made it right and adjusted the situation to satisfaction. I mean, I agree with you. I mean, I run a manufacturing company too. I could never imagine saying, oh, we are 100% perfect. That would be an all-out lie, but we do everything possible to make sure that it's about as good as it can possibly be all the time.
And that goes back to, I mean, that was based on my experience as a technician, and that I didn't build strategy milling because I wanted a second house in Naples, or I wanted a boat, or I want to live in a castle. I have
Those things would be okay though if you had them though, right?
you know what? I'm really not that interested. Quite frankly, I drive a 10-year-old car that I drive. I live in a small apartment. That stuff doesn't turn me on like seeing what I'm cultivating here turns me on.
It's a passion.
So we, I don't know where we are in our conversation line here, but we talked to Rotors, and we said we're not. So we have these stipulations about how fast they can mill a crown and the surface quality that we were looking for. And we said, we have a puck that's viable. I need to go someplace. You need to tell me who has a mill, like we're asking you about, that will allow us to come in and cut one of these crowns and test this out. And they found us one, and we traveled to California and put the puck in the machine. They sent a German engineer, as well as one of their local Rotors technicians out to that company with me. And we were there for 2 days test cutting. Miserable at the beginning, 45, 50 minutes to cut one unit. Didn't look great. We saw some things related to our alloy that we didn't like. So after 2 days, we cleaned out that mill and came home, refined all of the stuff that we pulled out of the mill at my brother's refinery. And we went back to the drawing board and fixed what was wrong on our side. Rotors did the same thing. And I think it was about 3 weeks later, we went back out and did that again and had our success on our second trial. And they reached the time that we were asking for, and the quality aspects. There were still things to take care of, but we saw enough advancement between those two testings that we were happy to go ahead and sign the contract so that we could get the mills built, because it takes about 6 months for them to build one of these, and then ship it over from Germany, and then get it on the floor, and then set it up, and then test it, and go through all of the process. Because you don't just open a box up one day and turn it on and cut parts. That's not how that baby works. So that's the condensed version of how we ended up here. And with 3 mills on the floor, we were right around February of 2012, sorry. And we were trying to get ramped up to go to Chicago. And then we had big dreams, right? We were going to go to Chicago and launch this, and then we were going to go to the IDS that year and show it off over there.
Brainski Unleashed is powered by ProfitMax. Did you know that 93% of businesses overpay on their taxes? Do you pay too much in taxes? A recent study showed that businesses are overpaying between 34 and 71%. ProfitMax has proven, legal tax strategy solutions to reduce your tax burden. I'm not only a client, but I even joined the team to help other business owners just like me pay only their fair share and nothing more. Go to profitmax.co. That's profitmax.co. profitmax.co to find out more. You can even connect with me there, as you should. And I'll help make sure that your tax bill is legally as low as allowed. ProfitMax. Keep your catch.
And when Scott talks about Chicago happens to be the biggest dental trade show in the United States, and IDS happens to be the biggest dental trade show in the world. So that's what he's talking about there.
Right. Yeah. Thank you for that clarification. That's what we wanted to, unveil this thing. And so my father, who he's downstairs, he's here, he's 84, he still works here. It's like a total cycle change because I used to work at his place. But he was the one that looked at everything and said, "Are you sure you're ready?" I said, "What do you mean?" We're all pumped up looking at a couple of crowns that we made. And he's like, what happens if it really goes? Are you really ready? You could kill your own business by launching prematurely and not being ready for what could happen. Think about that. And we did. And we said, you know what? He's right. We probably should pull back on that. And so what we did was we spent 2013 with a select group of laboratories that were our beta test customers. sending them cases and listening to their feedback, fixing what they didn't like, changing things, and then really getting knowledge about how to run these mills. They're very sophisticated. They're not, if I turned one off, you could probably lay a gold bar on the table to pretty much anybody and say, if you can get the mill turned on, I'll give you the gold bar. It's not like you just turn a switch and push a button. There's a whole process to launching one of these mills and getting it to run. So he was right, and it was great that we spent 2013 in what we call a soft launch, just hearing the voice of the customer, fixing what they didn't like, dialing in things for better surface texture and finish, making refined anatomy in the occlusal anatomy grooves, because we didn't have a sequence for that. So you have to spend a lot of time with your CAM developer, those engineers, to figure things out. Even tooling, I mean, that's a big one, right? Mugi has been our tool vendor for years. And when we told them what we were doing, I mean, they sent a team of people in here to try to understand, and looking at your alloy, looking at Vickers hardness, elongation, elasticity. How is this going to cut? What material is that like that we're currently cutting, that we can glean some information from as to what all those pieces are? Step over, step down, feed, speed, what tool, what coating, how many flutes on the tool, what tool holder are we going to use, what RPM are we going to spin at? You know, all of that stuff has to be, it's not easy. It's so far in the past, I'm happy. But I can tell you that even today, now with milling 6 alloys, we are right now going through a deep dive, and it involves changing a number of things to maximize tool life, because that means you're maximizing your tool cost. So, you know, once the big problems get out of the way, you then spend your time drilling down, no pun intended,
on the smaller problems. Yeah.
Right. And those small problems, just in the last few months, I saw our tool bill spike. And I'm like, time out, something's going on in here. We've never had bills like this. So what's happening? And now you have to change, you know, it's a small staff of people running a pretty busy operation, lots of automation, but where the human interaction is, a new employee who doesn't understand a couple of fine points that were not trained, he wasn't trained properly, and that's my responsibility. There were some things that got missed, and suddenly good tools are being removed and replaced with other good tools, and you're watching your tool bill go through the roof. So yes. It's a cause and effect reactionary, because you can't hover over every single person all the time. They have to be empowered or it doesn't work. But when a bill shows up that is a glaring difference from all the other bills, then it alerts you that something's happening.
So you'd say that it's pretty important, actually, not just to simply run your lab, but also pay attention to the bills coming in, because the bills themselves can show you a problem that you can't just naturally see by walking around.
Correct. Yeah. I mean, if you walk through here we don't have time, I'm sure, on this podcast, but if we had a discussion here in an afternoon of what was going on, the Rotors machines collect so much data on tools, the wear out, how much wear they are using, how much, because every time the tool is put away, it's measured with a laser, it's cleaned and measured with a laser. So there's a ton of data, how many meters it has traveled, what the wear is on length, diameter, and radius, what the time, how many hours or minutes or seconds has that tool been cutting. So it's almost, it could be somebody's a quarter of their job just to simply manage the tools and get everything dialed into a place where now we can leave that alone and we don't have to touch that. But when you start milling 6 different materials, all of them different, it becomes right now, it's one of the more monumental tasks we have going on the floor and it slows things down. Right? Because you can't just go to the machine anymore and look at all the red lines, pull those tools, replace those tools, and go about your day. Nope. Now those tools have to be examined. I need a screenshot of that tool belt page on the computer so that we can identify what's happening, where's the tool wear, talk to Mugi or any other tool vendor about what coating we might have, how many flutes we have, what RPM are we at, are we getting it's just almost endless. The data to collect and
Yeah.
decipher to make that right.
I mean, look at what you're doing. I mean, you're literally just diving so deep into the detail of your manufacturing process. Again, this is one of those areas where most conventional labs never go anywhere near this. You know, they'll go, oh, you know what, we're getting chipping, we're gonna throw out a tool, or oh, look at that, the screen says that the tool's dead, so we're gonna throw out a tool. When you know, chipping is always a sign that there may be a problem. Maybe it's not even the tool. You don't
Right.
know that.
Could be vibration.
You know, it could be vibration, something could be out of calibration, maybe the table itself, somebody moved the table.
Right.
I mean, there's
Right.
so many things that could cause that problem. And you know, typically in most laboratories, I'm guilty of it myself at times, is you become so reactionary. So I think, you know, I give you a lot of credit for a lot of the proactive approaches that you're taking. They are in essence reactions, but you're taking very proactive approaches to resolving those. And I think a lot of dental labs are so weak with that, and it's sad. And my hope is that, you know, anyone that is actually listening this podcast or watching it, because it's watching as well, can glean some sort of insight on that, as far as take a pause and try and figure things out and document things. I can tell you, because I'm with Profit Max, is that would also qualify you for research and development tax credits, which then helps pay for the fact that you're taking the time, because that time does have a cost. It's waste, you know, waste on tools, waste on materials, waste on, you know, time
Right.
and energy and machines. But that is something that you could actually get paid back for through these R&D tax credits. But to do that, I think, makes a massive impact on how you produce, because now you take strategy milling compared to what was, you know, in the beginning. And where are you with tool cost when you are not currently suffering from someone making a mistake? Like when things are really humming and you're milling and things are just running beautifully, where are you now versus where were you before?
We're obviously at a lower price per unit on tool cost than in the beginning, where we were blindly throwing good tools out because we weren't understanding the data that was being presented.
And
Yeah.
therefore you are probably predictable, right?
Right.
I mean, would you say that your operation is a predictable operation, where you know you have X amount of units before you even have to think about, I'm going to have to change a tool, or we're going to have to make a new puck,
Yeah.
or service a machine, or
Yep.
change a collet? I
Yeah.
mean,
We
you
know
should have.
on average how many units we're going to get out of a puck. We know on average how many tools we're going to use. All that data is sitting there. And with the deep dive we're doing right now, we'll probably be able to advance those numbers in our favor even further.
And I mean, are you at the point now, or do you feel you'll be at the point soon where you can schedule your machine's maintenance out into the future, knowing that, you know, come December, based on the trajectory that we have, that we know we're going to have to take, you know, machine number 3 down for its, you know, annual maintenance, because of, you know, this is, you know, these are the metrics that go into that. I mean, are you at that point?
I mean, we do preventive maintenance annually on the machines, and
I mean, they're durable machines, but you're still going to have to do maintenance on them.
yeah, it's a lot less than what you would think. And that's because of the price tag. I have to say, we stepped into these are per platform on the floor. And when I say platform, it consists of the mill and then the magazine cell with the robot that manages puck and cups and units. It's $500,000 per site, and we have 5 of those. It's an annual fee that we pay rotors, and they come in to do the maintenance on them. But because you step into you know, there's a machine that's well, I'm not going to name what it is, for obvious reasons. A lot of mills that are not in this price point range run with metal to metal parts that touch each other, which obviously wear over time, which means there's slop in how the parts are, the precision that machine can deliver. And by stepping into a machine like the rotors RXD5s that we're running, and RXD5Cs now, that have even got race cut on them, which is another thing we can talk about. But those machines, the movement of the parts, there is no metal to metal that touches itself that can wear. So there's stainless steel rails basically that have a mechanism attached to them that slides on an oil float.
Mhm.
And those are being pushed by pneumatics, by air power, back and forth. And there's also a maglev belt inside the machine that moves the spindle around. And so these machines are called 3G machines, which means the way I describe it to people is, if you could shrink yourself down and get on there, you would feel 3G forces as that thing is moving around when it changes direction. So that's the speed that it's changing direction and moving. And it's doing that with precision because over time, nothing's wearing out.
Well, the fact that you said it's maglev, I mean, that's zero friction.
Right.
It's incredible.
So I think the software is, I'm going to get this number wrong, but it's something like the software in the computer is reading the location of the tip of the tool 32,000 times a second. So that's the difference, right? If you're going to, what are those? Those are my technicians. We talked a little bit before we started this podcast about the asset, not the job. Yes. Right. And I am building an asset here that makes something. And what asset do I want? What's the foundation that I want to stand on to do this? And I was told, I've been told I'm crazy, but somebody bragged to me that they bought 13 machines for the price I paid for 3. Good. Because you bought 13 machines that don't do what these 3 do. And I always make the comparison, and I'm sorry to Germany because to me, Porsche, while a fantastic car company, that name doesn't have the same impact in conversation to say, I have 5 Lamborghinis sitting down there,
right,
that I run every day. And
well, I mean, look, almost everyone can have a Porsche. If you drive around the streets these days, there's a lot more of those than you see Lamborghinis or Ferrari, right?
And I'd probably rather have a Porsche than a Lamborghini, but in that conversation, right, in that phase, it makes more impact to say, look at what this is. And so when they're performing at that level, what it leads to ultimately gets back to the conversation we were having earlier about my experience with my outsource partner. Across 10 years of all the products that we have milled and sold to our customers, our external remake rate stands at less than 0.5%.
Which is, from a dental lab standpoint, is absolutely
right,
mind-blowingly low.
I just recently saw a lab's website where they said they hold the industry's best external remake rate at 2.3%. Okay, that's great. We're at 0.4, 0.5. I don't believe we've hit 0.5. I say below 0.5% because it fluctuates between 0.3 and 0.4. Mm-hmm. So that's what I'm trying to get Strategy Milling to be able to deliver to the customer. When I was receiving a case in the mail from Issaquah, no, not banging on them. What was my expectation? My expectation is I'm going to open the box. I'm going to put that thing on my die. It's going to be right. I'm going to move it over to my porcelain department. And I'm going to start putting porcelain on this thing and fire it because I can be done with this in 2 hours. Not that I have to bring it in, unpack it and go, damn it, and then go backwards in my own process back to an earlier stage than I wanted to and start the refitting and remachining process to get that thing to go out of the lab. That's not what my goal was for Strategy Milling to produce. So, that's in a nutshell the milling side of what we're trying to do here. And I don't know if you still have time and you want to continue.
I mean, we can't go all day. However, I can certainly have you back. But I do want to at least just focus for a few minutes on just some of the differences. Now we understand the quality. We understand why the quality is there. So let's at least take a look at the difference between what you do and what traditional casting is, or even what laser melting is, because the difference from an engineering manufacturing standpoint is obvious. And I think we've articulated that really well. But what is the end result? Why is it people should work with you versus anybody else? I can tell you why they should work with you because I am a client of yours and I get the best possible product, hands down, consistently every time. Sans 3 cases over a few years, but that's fine. What is it that people are missing from your opinion as to, you know, they obviously are doing the old school way or they're going elsewhere. What are they missing? Why aren't they getting it?
Yeah,
Connect the
so
dots.
I'm glad this is what I wanted to, this is why I asked if we had more time, because I did want to touch on this.
Yeah.
So, let's just start with the basics. Analog, let's say there's analog casting, which is the traditional way that the inventors were the Mesopotamians 3,000 years ago, right? That's how old that technology is.
Which functioned for a long time, but it lacks accuracy and repeatability.
Lacks a lot of things.
I mean, consistency, accuracy, repeatability.
So
Ooh.
there's that. There's laser sintering or SLM, laser melting, select laser melting, and there is reductive manufacturing through milling. So what's wrong? Let's leave laser sintering out for a minute and just compare. You'll figure this out along the way. So the analog process with traditional casting, I thought that was pretty cool. I loved working with metal. I've been working with metal since I was a teenager, welding and doing other things. So welding to me was, those things to me were, it was in my blood basically to work with metal. And I used to think I could cast bridges in one piece and they fit. And I will say they were clinically acceptable. But now that I've seen what fit really looks like, I can argue that point. And the other piece is the attachment that we have as technicians. When you've poured your time and your energy and your skills into trying to create this thing, you don't really like it when somebody tells you it's not right. And so there's a lot of ego pushback. And I get it. I was the same way until I saw the way, which I'm going to say is what I'm watching now. The other thing that happened in building strategy milling was I talked about how I'm now a refiner. You know, I run a foundry and I run a machine shop. Well, I also had to learn a whole lot of metallurgy to make those pucks well. And in that process, as you make discoveries along the way, you start realizing, it starts making you realize how flawed the lost wax casting technique really is. And it's not just flawed from a couple of the things that you mentioned, accuracy and consistency. It's also flawed because in strategy milling, when we process a series of pucks out of any alloy, the first thing that we cut from any of those pucks are little cubes. And those little cubes, depending on what alloy it is, if it's a crown and bridge alloy, which we make gold crowns from, those cubes get sent off to another company that they take them and do destructive testing on them and give us an inductively coupled spectrograph report back of what the elemental makeup is of that alloy. We alloy our own materials. So that means I'm buying gold, platinum, palladium, silver, tin, zinc, gallium, a number of other things on the market, and then following recipes to create the dental alloy that we sell, that we sell as crowns and bridges. If you don't test that material, every time you melt that metal, something vaporizes.
Something changes. The composition slightly changes.
Composition slightly changes. When you see as a lab who's done analog casting and you read the little label that comes with your material that you bought from one of the alloy manufacturers, and it talks about adding 50% new metal, there's a reason for that. It's not that they just want to sell you more stuff. It's because you're changing the composition of the alloy. And if you don't do that, after you've cycled that metal a few times where you melt that button back down and make your next case out of it, and then suddenly one day your porcelain starts to fracture or bubble. That's a different issue, but your porcelain fracturing means you've changed the coefficient of thermal expansion of that alloy, and it's no longer aligned like it was when it was manufactured to your porcelain kit.
It's out of spec.
Out of spec. Every time we cycle the alloy, we send off for that testing. If it's a PFM alloy, we also send off for carbon and oxygen analysis. So there's two different companies doing two different sets of tests. We save another sample that we mount and polish and etch for grain structure and porosity analysis. So what laboratory is doing that?
None.
Right.
None.
So
None.
it's the
Even the other manufacturers that do this stuff, Scott, none. Not even close.
and so between 2015 and 2018, we decided what's the obvious next step for strategy milling after having had success milling a noble and a high noble crown and bridge alloy. The next obvious move is PFM. What if we could mill PFM? Look how nice the cobalt chrome that's milled works. Look how nice milled titanium works. So milling works. So let's solve the problem of making a semi-precious and a high noble and a noble PFM alloy. Well, I spent 3 years trying to make a PFM puck from a palladium alloy. And by the end of 3 years, I was in debt for $1 million because we could not solve one of the problems. So I had to stop and I had to pay off the $1 million. And when we were done paying off the $1 million, in the time that it took us to pay off the $1 million, part of that we ran into COVID. So that was fun, right? No stress, no pressure.
Good times.
And we're trying to resolve this technical issue so that when the day comes, because the day will come that we pay off that debt. And when that day comes and I get refinanced and I get my line of credit restored, I'm doing this because it has to be done for the industry, is my opinion. I know everybody's been telling me for 10 years that metal's dead, and we're still here, and we added 2 machines last year. So that's my answer to the question, isn't metal dead?
Yeah.
And so over that time frame where we discovered what the problem was and how to solve it, we got refinanced in 2000, whatever it was, whatever year it was, I don't remember. And we immediately turned around and made the investment into the new PFM alloy. We have a 1.5 years or so track record now of producing PFM alloys that are milled that have no issues related to them. So that's important in this conversation because nobody who's analog casting, I've heard of one lab. I don't know the name because the technician didn't tell me who it was, but one person I had this conversation with in the last couple of months said she knew of a lab that did this type of testing, or they did add, at least they added the 50% new alloy.
Yeah.
And if you're doing that, that's great, but you have to have a pretty financially strong, robust laboratory to do that. And then because the metal that you send out to scrap, you'll get paid, but you're going to still lose money on it. It's not a winning game.
You lose a fortune.
Right. So you have to be making an exponential amount of money to afford to be able to do that. That's great if you can. Most labs can. We've developed a process by which every time we get those ICAP results back, we plug them into our software. It tells us what the deviations are. And we've developed a whole nother process, have a special furnace for it here, where we can basically create a master alloy that restores the missing elements in the missing volumes back into the next round when we make our pucks again. So that's the piece compared to analog casting. And then milling on a machine like this, just hands down, and I mean, to take a roundhouse bridge and deliver that substructure to a customer in a basically finished state, where all they really have to do is knock the leads off where the attachments were, put it on their model, check a few things. Some of the embrasures, if there's tight spaces in between 2 teeth that we can't mill, you might open that up with a disc. Other than that, you're sandblasting that, cleaning it, heat treating it, and it's off to the ceramic department.
Yeah.
We get fantastic density because of how we manufacture the pucks. And because of that and the grain structure that's developed, things like margin creep that have been written about for years in LMT and other magazines.
Never a factor.
Never going to be a problem because of the grain structure and the density that we can create by having a puck. So those are some of the bigger issues and advantages of milling over casting. And then when you compare that to SLM is welding at a microscopic or tiny scale. Anybody that's seen somebody weld with an arc welder, TIG, MIG, arc, whatever, the welds are rounded off large things. They're not precision sharp.
Yes.
If you want it precise, you have to sit there and finish that again.
Yes, it's so imprecise. And that's what we experienced was, when we were doing the SLM thing, before I even came to you for services, it was the imprecision that we were getting was so disappointing that we thought we've just got to go back to the old way, which we felt was more accurate, amazingly. And then, of course, we saw the light with you. Unfortunately, Scott, we are out of time, so we do have to kind of cut this short. I would love to have you back and probably continue the conversation. You have so much knowledge. To me, you're fascinating to talk to, and you learn so much when, I learned so much when I talk to you, and I'm sure, there's people who are listening to this have. So I thank you so much again for joining me, Scott. It's been an absolute pleasure, and let's try and schedule this to do this again. Round two.
Absolutely. Thank you for the opportunity, and I appreciate all your gracious remarks and comments. I'm happy to share what I can, because I'm here to try to advance what we're ultimately all here, I believe, to do, and that's provide really fine medical devices to patients that last them years and years and years for their benefit.
Excellent. Well, thank you again, Scott.
Thank you, Tom.